Normal distribution. The way you draw a normal distribution curve is you start out with a bell curve. Draw a smooth one, split it down the middle at the peak. That will be your mean, median, and mode. Draw the outmost lines on each side, then split that area in half. There's a great explanation of this at this link. So, first you're going to make a bell-shaped curve. Then you're going to go to the peak of the curve, and you're going to draw a line down. That'll be your median. You'll draw lines on each side, split that area down the middle, and that will be what we're going to talk about in a moment, your 68 and 95%, and also there's going to be a 99.7%. But before I get to that, I just want to talk about what a standard deviation is. If you look here, your median or your mean is down the middle, so your standard deviation is 1 over. Your standard deviation of 1 can be 30, it can be 10, it can be 7, but you move 7 over if it's 7, and that's 1 standard deviation. The empirical rule says that when you move one standard deviation to the right and 1 standard deviation to the left, you are gathering up 68% of the information of the data. When you move 2 standard deviations to the right and 2 standard deviations to the left, you're gathering up 95%. So you're including these 68% and you're gathering up 95% of the data. And when you move 3 standard deviations to the right or 3 standard deviations to the left, you're gathering up 99.7% of the data. Once I have the 2 bits of data, the standard deviation and the mean, I can answer a lot of stuff just by drawing a normal distribution curve. So what I will do is always follow the steps of the standard deviation curve. For instance, if I say to you, I have a mean of, what is the age of people who like Adam Levine? If the mean age of people who like him is 24 with a standard deviation of 6, that means if I draw my curve and draw a line down the middle, I will put 24 right there at the middle. And it has a standard deviation of 6. So if I move over 1 to the right, I move up 6. That gives me 30. And if I move 2 standard deviations, I go to 36. And if I move right 3 standard deviations, I go to 42. Same thing on the other side. If I move 1 standard deviation to the left, now I drop down to 18. If I move 2 standard deviations, that means I move 6 down, and then 6 more down, that's 12 down. So that gives me 12. And if I move 1 more standard deviation, I'm moving 6 more down, which is 6. So let's look at what we have here. The mean for people who like Adam Levine, their age is 24. If I move 1 standard deviation to the right and to the left, I'm at 18 and 30, and that means by the empirical rule, 68% of people who like Adam Levine are 18 to 30-year-olds. If I move 2 standard deviations to the right and to the left, that means I've gathered 95% of the data, and that puts me at 12 years old, and at 36 years old, 95% of the people who like Adam Levine are between the ages of 12 and 36. And finally, if I move 3 standard deviations to the right and to the left, I'm gathering 99.7%. So that says 99.7% of the people who like Adam Levine are between the ages of 6 and 42. Now, I don't know if that's true. I just made up those numbers, by the way. So again, the first thing you do when you have your standard deviation and your mean is you draw your bell-shaped curve. Then you draw your mean down the middle. Then you draw the outermost lines, and sometimes they go to 3 standard deviations. So at this point, you can split it down the middle to have 2, to split the area in 2 on each side, or you could split the area into 3 on each side, which is this right here. And it's best to use the one with 3 because you get all the way to 99.7%. But sometimes I get lazy and I just use 2 standard deviations, to the left and to the right, where I just split it into 2 on the left and on the right. So there's also some cool reasons for the next part, but it comes down to knowing that 68% can be divided into 34 and 34%. Memorize 13.5 after that on each side and 2.5 on each side. So now you have 34% and 34%. So you could just really just go 1 standard deviation and read that. Or you could go 2 standard deviations to one side and add the 34 and the 13.5. Also here, this went 4 standard deviation, so it's split up to 2.5. It really didn't split up, but put 2 and 0.5. But I stop usually at 3 standard deviations and just make that whole part 2.5% on each side. So that stuff is always there, what I just said. You can use these by lining up your ages or your scores or whatever with the standard deviations. For instance, this is the way that you're going to use this normal distribution curve. If I tell you that the people who take the IQ test have a mean of 100 and a standard deviation of 15, and these are 2 different pictures, but they say the exact same thing. Some people like to put the standard deviation on the bottom. Some people like to put it on the top. And some people like to use colors to represent it. But no matter how you look at it, the 68% of people who took the IQ test are between 85 and 100, got between 85 and 115 on it. 95% includes that 85 to 115 people. Even though this is pink and blue down at the bottom, it does include the blue, and that means they've scored 95% scored between 70 and 130, and 99.7 scored between a 55 and a 145. So let's use this information on what I've seen on a test question before. The number of books borrowed from a library follow a normal distribution with a mean of 190. Bam, you already know. I'm going to draw my line, my curve, go down the middle, and put my 190 there. And a standard deviation of 30. So from that 190, I'm going to go in increments of 30 for every standard deviation. So first thing I did was I draw my 190, and then I go 1 standard deviation to the right and 1 standard deviation to the left. That means I'm going to add 30 and minus 30 to get my next numbers. And that's 1 standard deviation gets me to 220. 2 standard deviation means I go 30 more. That gets me to 250. And also on the left, you go in increments of 30 for each standard deviation. Then I line up my information, my standard deviations. And now I know where my percentages are because it's always the same using the empirical rule. 68%, 95%, 99.7%. 68%, which 95%, and 99.7%, which you can then break up. So I go to the test question, and I see that it says, one second. I go to my test question, and I say, there is a 16% chance that more than 250 books are borrowed in a week. Well, let me look at my graph. More than 250 books are borrowed in a week? No, because after 250 books, it's only 2.5%. How about choice B? There's a 2.1% chance. Well, that looks like it could work. It pretty much supports it. It's close. It looks like it might work unless there's something better, but I'll take one more look. I have 250 books borrowed in a week. It's around 2.5% that are more than 250 books in a week. So go ahead and keep that one in mind. Then I go back to the question. There is a 68% chance that fewer than 250 books. That's saying there is a 60% chance that fewer. So I go to my graph that I made, and I see that already from 130 books borrowed a week to 250 books borrowed a week, there's a 95% chance. So since I did see that 95% is already just 130 to 250 books, you know that there's more than a 60-something percent chance. So you know that that 68% chance is wrong. Then you go to the next one. There's an 84% chance that more than 250 books are borrowed in a week. Well, you know that's not right either. There was a 2-point-something% chance that more than 250 books are borrowed in a week. And finally, the last one says there's an 84% chance that fewer than 250 books are borrowed in a week. You look at your graph. It's all about looking at your graph. This isn't something that you do mathematically. It's something that you look at and you read it. Just like I think it was option C with 68%, you know that 95% already go from 130 to 250, so you know that already that's too low of a number for fewer than 250 books per week. The last thing I want to go through is a quick clue for a test question that I keep seeing. Make sure that when you see a question like this, that you look at the middle of each of your data once it's lined up in order. Make sure everything's in order. And then you look at the middle, and the more of the same number that you see in the middle, the more of a normal distribution curve it is, as long as things are kind of even on the sides. So you look for whatever has the more of the same thing in the middle. For instance, there's 4, 4, 4. Okay, that's 3 of them. There's 7, 7, 7. Okay, then that's 3 of them, and so on. The one that has the least amount of the same stuff in the middle is going to be the one that is not close. It's the farthest from a normal distribution. Thank you for listening, and have a good day.